Welcome back to geometry. Today we are going to be talking about areas of regular polygons. Okay, so areas of regular polygons. Now the formula to find the area of a regular polygon is 1/2 perimeter times apothem. P stands for the perimeter, and A stands for the apothem. First off, where does that even come from? Well, when you look at a regular shape, it's like here, let's pretend that I just drew a regular octagon. A regular octagon you can split up into individual triangles. To find the area of each individual triangle, it would be 1/2 base times height, where the base would be all of these lengths along the outside. Well, if we add up all those bases together, we get the perimeter. And the apothem here is going to stand for that height of each individual triangle. So the apothem goes from the center of the polygon to the edge, and it must form a 90-degree. So here on this diagram, that length would be the apothem. Okay? Typically, to find the apothem, we are going to have to use our knowledge of right triangles. Okay? So we'll be using a lot of 30, 60, 90s, and we'll be using a lot of sine, cosine, tangent. So we want to find the area of RSTUV right up here if the perimeter is 60 centimeters. So first off, we know that the area is 1/2 perimeter times apothem. So we already have the perimeter is 60. We now need to figure out what the apothem is. So what we're going to do is we're going to take this triangle that has the apothem on, and we are going to draw it larger. So we are searching for that apothem right there. Now, if the perimeter is 60 centimeters, there are 1, 2, 3, 4, 5 sides. So to figure out the length of each side, I can take 60 and divide it by 5. If I do 60 divided by 5, I find out that each side length is 12. Now notice carefully where this triangle was drawn. This triangle was drawn from the center to the edge, forming a 90 and over. So that length right down here, that's not 12, but that would be half of 12, or 6. So right here we have 6. Next up, we need to figure out what this angle measure is. Well, that's something else we can find out from the fact that this has 5 sides. So if we think about how many triangles this would be broken up into, there would be 1, 2, 3, 4, 5 triangles in this pentagon if we broke it up. Total degrees in a circle is 360. So if we do 360 divided by 5, that gives us 72 degrees. So each of these triangles has a top angle of 72, but we're just dealing with half of that triangle. So we're then going to want to take the 72 and divide it by 2, and we're going to get 36 degrees. So once again, we took 360 divided by 5 because it's a pentagon, and we got 72, and then we divided that by 2 to get our 36. Now looking at this, we can find the apothem by using tangent, because with respect to 36, 6 is our opposite side, and A is our adjacent side. So we can use our tangent function, which says the tangent of the angle, so in this case 36, should equal your opposite over your adjacent, TOA, so 6 over A. To solve for A, we have to multiply both sides by A. So then we have A times the tangent of 36 is equal to 6. And then to get the A alone, we'd have to divide by the tangent of 36. So A here is equal to 6 divided by the tangent of 36. And when you figure out this value, you get about 8.258. So we're going to take that value and put that in for our apothem. So now, when we go to find the area, we can do 1/2 times 60 times that length of the apothem that we just found, and your answer button is very helpful it's ANS, very helpful for finding the areas. So this area is then 247.7, and this said centimeters, so centimeters squared. All right, we're going to do another example. This time, our regular shape is a triangle, but we are still going to use our area is 1/2 perimeter times apothem. So first off, we're told this is 14. So to get the perimeter, we would do 14 times 3. Well, 14 times 3 is 42. So the area is 1/2 times 42, and now we need to figure out that apothem. That apothem is right here. So we're going to look at that triangle. The whole length is 14, so just this is 7, looking for the apothem. Now we need to get that central angle in there. So this is 3 sides, so we can split this up into 3 triangles. So to get that angle, we would do 360 divided by 3. 360 divided by 3 is 120, and then we divide that by 2 to get 60 degrees. Ooh, look at this, 60 degrees and a 90 degrees. That is like our 30, 60, 90 triangles, where we have x, 2x, and x square root of 3. Well, here, we know the side across from 60 is 7, so that's our x square root of 3 side. So to get to our shorter leg, we would just have to divide that by the square root of 3. So our apothem here is 7 divided by the square root of 3. So if we do 7 divided by the square root of 3, we get a value of about 4.04. So that's our apothem. Now if we take that apothem and multiply it by 1/2 and by 42, the area we end up getting is about 84.9 meters squared. Okay, we're going to do another example. Same idea every time though, 1/2 perimeter times apothem. This is a length of 10, so the perimeter here would be 10 times 5, because there are 1, 2, 3, 4, 5 sides. So 1/2 times 50, now we just need to find the apothem. So we're going to set up that triangle. So if this is 10, half of that is 5. Here's our apothem. To get this angle, since we had 5 sides, we'll do 360 divided by 5, which is 72, and divide that by 2 is 36. This is our opposite side. A is our adjacent side, so we can use tangent. So the tangent of 36 is equal to our opposite over our adjacent. So to solve for our adjacent, our apothem, we multiply by A. So we have A times the tangent of 36 is equal to 5, and then we can divide by the tangent of 36. So if we take 5 divided by the tangent of 36, we get about 6.8819, so that's our apothem. So if we use that apothem, we times it by 50, and then we times it by 1/2, the area for this pentagon is about 172.0 inches squared. As you can see, this really is the same process. You just have to get the idea of how to find this apothem. We'll do 2 more examples here, and then there will be another supplementary video on this as well. Next example. This once again has a side length of 10, except for this time we have 1, 2, 3, 4, 5, 6, 7, 8 sides. So the perimeter would be 10 times 8, or 80. So we have 1/2, our perimeter of 80, and now we need to find the apothem. So we'll draw that triangle out. This whole length is 10, so that's 5. Here's our apothem. To get that angle, we would do 360 divided by 8, because there were 8 sides, to get 45, and then divide that by 2 to get 22.5, or 22.5 degrees. This is, once again, we can use tangent. We have the opposite side and the adjacent. So tangent of 22.5 is equal to 5 over a. Get the a alone, so we multiply both sides by a. So now we have a times the tangent of 22.5 equals 5. To get the a alone, we divide by the tangent of 22.5. So if we take 5 divided by the tangent of 22.5, our apothem is about 12.071. So we can fill that in for our apothem. Now if we multiply our apothem by our perimeter and then multiply it by a half, the area of this octagon should be about 482.8 inches squared. And we will do one last problem for today. 1/2 perimeter times apothem. Notice here we have a length of 10.9. There are 5 sides. So if we take 10.9 times 5, our perimeter is 54.5. And then look here. We were given the apothem, so we were given that 7.5. So we don't need to make the triangle at all. We can just fill it in. So if we take half times our 54.5 for our perimeter, times the 7.5 for the apothem, the area of this pentagon is about 204.4 meters squared. All right, so that's how you find the area of regular polygons.